You can see here some values for kappa for different materials. For many everyday materials it's quite low, but researchers are working hard on making new materials with very high dielectric constant, sometimes up to the tens of thousands. Why is this so important? Let's look at some of the uses of capacitors. We know that the size of the capacitance depends on the area of the plates. Pacemakers require a very high capacitance. It's only possible to make a pacemaker small enough to fit in someone's chest because of materials with very high dielectric constant. The specifications for a pacemaker are shown there, and you'll work out the capacitance in the end of lesson quiz. Capacitors have many other uses, some of which we'll look at later in AC circuits. Because they store energy, capacitors can be used in the same way as batteries, though usually for short bursts of current, like you need in a camera flash. You will also find capacitors in the UPS or uninterruptible power supplies for computers. They charge up while the power is on, and if the power is cut, they can provide current for long enough to let the computer back up and power down safely. Researchers are working on supercapacitors as an alternative to batteries for power storage. These capacitors combine complicated geometries and very high dielectrics to achieve capacitances of several farads, which is huge. It could be a good student project to research what capacitors are and what they're used for.